All right, so good evening again. So we're starting chapter 6, which is functions. Um, so let's start by looking at some definitions. So to the left, we have top left, we have the definition for a mapping. This says let A and B be non-empty sets. It says a mapping from A to B is a rule which associates a unique member of B to each member of A. A is called the domain of the mapping, and B is called the codomain of the mapping. So I'm guessing to the right over here, you probably could see an example of a mapping. So it says what, a mapping is a rule. So maybe that's not the perfect example. It's some rule which associates a unique member of B to each member of A. In the past, I think that's what we just said a relation is. So let us assume that a relation is a mapping. Now, so in this relation, you have what? Two groups, let us say, of numbers. You have A, you have B, and the elements of A are mapped to the elements of B, like that. Now, the elements of A, they are called the domain, and the elements of B, they are called the codomain. All right, so that's all that they have said. Now, that is nothing more than what we would have already learned from CSEC. So that is knowledge that we already know from CSEC. Now, what is a function? This says a function f of a set A to a set B assigns to each element A in set A, to each element common A in the set capital a single element f of A in set B. The elements in set B are called the image of A under F. So we're looking at the definition for a function. Now the set A is the domain of the function, and the set B is the codomain of the function. The range of the function is the set of elements that are images of A, which is an element of the set capital A. All right, so we'll get a chance to dissect that. So again, a function f it says a function f from a set A to a set B assigned to each element A in set element set common A in the set capital a single element f of A in set B. All right, so let us say to the right we have our function. The elements in A, they're called the domain. And the elements in B, they're called the codomain. All right. Now, the diagram we're seeing to the right is a function. So when writing the mapping as a set of ordered pairs, the first element in the ordered pairs must be the element in the domain, and the second element in the ordered pairs is the element in the codomain. So for example, the function over to the right here, I could write the elements of the function as a set of ordered pairs. The first ordered pair would be A, U. That's an ordered pair. The second ordered pair would be BV. So these, whenever you have your the elements of your function arranged like this, it's called an ordered pair. The first element in the ordered pair is the domain, and the second element in the ordered pair is the codomain. Now, a function is a mapping in which every element in the domain has a unique image in the codomain. At CSEC, we would say every element in the domain is mapped onto one and only one element in the codomain. Note that one arrow comes from each element of A. Thus, every element is mapped onto a unique element in B. Now, the domain of the function is the set A. So A, B, C, D, that would be the domain of the function. And the codomain would be U, V, W, X, Y, and Z. Now the range of the function is the set U, V, X. Now these are the images of the elements of A. So what we're saying is U is the image of A, X is the image of B, V is the image of C, and X is also the image of D. Now, the codomain is the set of elements that are possible, and the range is the actual set of values that are assigned to an element in the domain. All right, so that is something to try and sink in. So let's just go back over it a little. So to the right, we have a function. So that's our function. All right. Now the elements of A, those are the domain. The elements of B are the what? Codomain. Now the elements of B, which are actually images, which are actual images of the elements of A, those are the elements which are said to be in the range. So for example, all of B, which is U, V, W, X, and Y, all of B is the codomain, but only U, V, and X form the range. Now that we know what a function is, one of the first things you need to be able to do is test for a function. Later on, we'll go to look at the different ways of representing a relation, and we'll have to be able to determine if a relation is a function, regardless of the way it is described. All right, so we'll see that as we proceed a little bit further on. Now, how do we do the test for a function if the function is represented as an arrow diagram? Now, this is the test. If one arrow leaves every element in the domain, the relation is a function. If one arrow leaves every element in the domain, the relation is a function. Now, if more than one arrow, or if no arrow leaves any element in the domain, the relation is not a function. I'll say that again. If one arrow leaves every element in the domain, important words, every. If one arrow leaves every element in the domain, the relation is a function. If more than one arrow, or if no arrow leaves any element in the domain, the relation is not a function. All right, guys, with that in mind, I want you to do example 1 and example 2. You can type your answers in the chat. All right, so in example 1, we're asked to determine whether the mapping at the left is a function. All right, and it's clear that in example 1, the mapping is not a function. And what's the reason for that? You can see that the element 1 in A is mapped onto 2 elements in B. A is mapped onto what? Sorry, 1 is mapped onto A and 1 is mapped onto E. So by definition, this is not a function. And from the test says if more than one arrow leaves any element in the domain, the relation is not a function. By definition, it's not a function because for a function, we are told that every element in A must be mapped onto what? Every element in the domain must be mapped onto one and only one element in the codomain. Now, the element 1 in the domain is mapped to 2 elements in the codomain. Therefore, the mapping to the left is not a function. Example 2 says given A, the set A. All right, so let's write this. Let's represent this as a mapping diagram. So we have A, and the elements in A are 10, 20, 35, 70. The elements in B are 2, 3, 4, 5, 7, and 9. And we are told to consider the mapping is a multiple of. All right, so if you consider that mapping, well, 10 is a multiple of 2. 10 is also a multiple of 5. 20 is a multiple of 2. 20 is also a multiple of 5. 20 is a multiple of 4. This might not have been necessary. Yeah, it is necessary. 35 is a multiple of 7. 70 is a multiple of 7. 70 is also a multiple of 2. All right. I don't think any of these match to 9. So as a mapping diagram, as an arrow diagram, my relationship, the relation is a multiple of would look something like this. Next, we're asked for the domain. Well, obviously, the domain is A. So the domain is the set A, and B, the codomain is the set B, and next we're asked to say if the mapping is or is not a function. Well, it's clear that this is definitely what? Not a function. All right. 10 in the domain is mapped to 2 elements in the codomain. 20 in the domain is mapped to 3 elements in the codomain. So obviously this is not a function, because if it is a function, every element in the domain would be mapped to what? 1 and only 1 element in the codomain.